Welcome back to English So-So. I'm Sam, and today we're delving into one of the most intellectually stimulating topics in cognitive science, the art and science of memory enhancement. Have you ever wondered why some people seem to effortlessly retain complex information while others struggle to remember what they learned yesterday? The answer isn't innate intelligence, it's methodology. Today, we'll explore 7 scientifically validated techniques that can dramatically improve your ability to encode, consolidate, and retrieve information. These aren't just theoretical concepts. They're practical strategies that neuroscientists, polyglots, and memory champions use to achieve extraordinary results. Whether you're preparing for advanced examinations, mastering a new language, or simply wanting to optimize your cognitive performance, this episode will provide you with the tools to transform your relationship with learning and memory. Let's begin with perhaps the most venerable and powerful memory technique, the method of Loci, also known as the memory palace technique. This technique, which dates back to ancient Greece, exploits our brain's exceptional spatial memory capabilities. The underlying principle is to associate information with specific locations in a familiar environment, your home, workplace, or even a route you frequently travel. Here's how it works. First, you create a detailed mental map of your chosen location. Then, you place the information you want to remember at specific points along a predetermined path. The key is to make these associations as vivid and bizarre as possible. For instance, if you're trying to memorize a list of historical dates, you might visualize Napoleon Bonaparte sitting at your kitchen table, or imagine the Great Fire of London engulfing your living room. Research conducted at the University of London demonstrated that participants using the method of Loci showed a 73% improvement in recall compared to traditional rote memorization techniques. The technique works because it transforms abstract information into concrete spatial memories that our brains are evolutionarily designed to remember. Our second technique addresses one of the most counterintuitive aspects of learning, the strategic use of forgetting to enhance memory. German psychologist Hermann Ebbinghaus discovered what we now call the forgetting curve, the exponential decline in memory retention over time. However, Ebbinghaus also found that each time we review information, just as we're beginning to forget it, we extend the retention period exponentially. This principle forms the foundation of spaced repetition. Rather than cramming information in intensive sessions, spaced repetition involves reviewing material at increasing intervals, initially after 1 day, then 3 days, then a week, 2 weeks, a month, 2 months, and so forth. The optimal spacing intervals follow what's called the desirable difficulty principle. The information should be challenging to recall, but not impossible to retrieve. This mild struggle during retrieval actually strengthens the neural pathways associated with that information. Modern applications like Anki and SuperMemo have algorithmically optimized these intervals, but you can implement spaced repetition manually using a simple card system. The key is consistency and precision in timing your reviews. The third technique leverages our brain's natural tendency to remember information that's meaningfully connected to existing knowledge structures. Elaborative encoding involves creating rich, detailed associations between new information and what you already know. Instead of memorizing isolated facts, you build comprehensive semantic networks that interconnect related concepts. For example, rather than simply memorizing that photosynthesis converts carbon dioxide and water into glucose, you would explore the evolutionary significance of this process, its role in global climate regulation, its connection to cellular respiration, and its applications in sustainable technology. This approach transforms learning from a passive absorption of facts into an active construction of knowledge. Each new piece of information becomes a node in an expanding network with multiple retrieval pathways. Neuroscientists have observed that elaborative encoding activates the hippocampus, prefrontal cortex, and temporal lobes simultaneously, creating what researchers call distributed memory traces. These distributed traces are remarkably resilient to forgetting and can be accessed through multiple cognitive pathways. The practical application involves asking yourself connecting questions. How does this relate to what I already know? What are the implications of this information? How might I use this in different contexts? What patterns or principles does this exemplify?
Named after Nobel Prize-winning physicist Richard Feynman, this technique is based on a deceptively simple premise. If you can't explain something in simple terms, you don't truly understand it. The Feynman technique consists of 4 steps. First, choose a concept you want to learn. Second, explain it as if you're teaching it to someone with no background in the subject. Third, identify gaps in your explanation and return to source materials to fill them. Finally, simplify and use analogies to make the concept more accessible. This process forces you to confront the difference between recognition and recall. You might recognize information when you see it, but true learning occurs when you can actively retrieve and articulate that information from memory. The Feynman technique is particularly effective because it engages multiple cognitive processes simultaneously: comprehension, organization, verbalization, and metacognition. You're not just memorizing, you're processing information at the deepest conceptual level. Research in educational psychology has consistently shown that students who engage in elaborative explanation, essentially what the Feynman technique promotes, demonstrate significantly better retention and transfer of knowledge to novel situations. Our 5th technique challenges conventional wisdom about focused practice. While blocked practice, studying one topic intensively before moving to another, feels more effective, research reveals that interleaving produces superior long-term retention. Interleaving involves mixing different topics, skills, or problem types within a single study session. Instead of spending an hour on calculus, then an hour on physics, you might alternate between calculus problems, physics concepts, and chemistry equations every 15 minutes. This approach initially feels more difficult and less satisfying than blocked practice. However, this difficulty is precisely what makes it effective. The constant switching forces your brain to actively discriminate between different types of problems and retrieve the appropriate strategies for each. Contextual variation extends this principle by studying the same material in different environments, at different times, and using different methods. This creates multiple retrieval cues and makes your knowledge more robust and transferable. Studies in motor learning, mathematics education, and language acquisition have consistently demonstrated that interleaved practice leads to 20 to 30% better performance on delayed tests compared to blocked practice, even though it may feel less effective in the moment. The 6th technique transforms testing from an assessment tool into a powerful learning strategy. Contrary to popular belief, the act of retrieving information from memory is not merely a way to measure learning. It's one of the most effective ways to enhance learning. Retrieval practice involves actively recalling information from memory rather than simply rereading or reviewing notes. This might involve closing your textbook and writing everything you can remember about a topic, creating mind maps from memory, or generating your own quiz questions. The testing effect, or retrieval-induced learning, has been demonstrated across hundreds of studies. The process of retrieval not only strengthens memory traces, but also creates new retrieval pathways and improves the organization of knowledge in long-term memory. Importantly, retrieval practice is most effective when it's challenging but not impossible. Some forgetting between study sessions is actually beneficial. It creates opportunities for effortful retrieval that strengthens memory more than easy recall. Practical applications include using flashcards, self-testing, teaching others, and creating desirable difficulties in your study routine. The key is to make retrieval an active, effortful process rather than a passive recognition task.
Our final technique might be the most underappreciated: strategic use of sleep for memory consolidation. Sleep isn't just rest, it's when your brain actively processes, organizes, and strengthens the memories you formed during the day. During sleep, particularly during slow-wave sleep phases, your brain replays the neural patterns associated with recent learning. This replay strengthens synaptic connections and transfers information from temporary hippocampal storage to more permanent cortical storage. Research has identified several ways to optimize this process. First, reviewing material before sleep enhances overnight consolidation. Second, maintaining consistent sleep schedules supports the natural rhythms of memory processing. Third, avoiding alcohol and excessive screen time before bed preserves sleep quality. Perhaps most remarkably, studies have shown that targeted memory reactivation can enhance specific memories during sleep. This involves associating learning with particular sounds or scents, then presenting those cues during sleep to strengthen associated memories. The practical implications are clear. Treat sleep not as time away from studying, but as an integral component of your learning strategy. Quality sleep can be more valuable than additional study hours. Now, let's synthesize these 7 techniques into a cohesive learning framework. The most effective approach isn't to use these techniques in isolation, but to integrate them strategically. Start with elaborative encoding to build rich conceptual foundations. Use the method of Loci for information that requires precise recall. Implement spaced repetition for long-term retention. Employ the Feynman technique to test your understanding. Employ interleaving to improve discrimination and transfer. Use retrieval practice to strengthen memory pathways, and optimize your sleep patterns to consolidate everything you've learned. Remember, these techniques require initial effort and may feel less efficient than familiar study methods. This temporary difficulty is not a bug, it's a feature. The cognitive effort required by these techniques is precisely what makes them so effective for long-term learning and retention. The human capacity for learning and memory is far greater than most people realize. These 7 techniques, spatial encoding, spaced repetition, elaborative processing, explanatory learning, contextual variation, retrieval practice, and consolidation optimization, represent centuries of scientific research distilled into actionable strategies. I challenge you to choose one technique from today's discussion and implement it consistently for the next 2 weeks. Document your experience and observe the changes in your learning efficiency and retention. Which technique resonates most with your learning goals? How might you adapt these strategies to your specific field of study? Share your thoughts and experiences in the comments below. Your insights could help fellow learners optimize their own cognitive performance. If this deep dive into memory science enhanced your understanding of learning, please subscribe to English So-So for more advanced content. We publish new episodes every Tuesday and Friday, exploring the intersection of cognitive science, language learning, and personal development. Until next time, remember, mastery isn't about innate ability, it's about strategic application of evidence-based techniques. Keep learning, keep growing, and I'll see you in the next episode.